observations on stereo would encourage NASA to take advantage of any relatively low-cost mission that they could underfly with IRIS. And certainly balloon flights can be rescheduled. They're not free, and neither are rockets, so planning has to occur and budgets have to be found, but hopefully they will be.
I would just like to add that we certainly try and coordinate whenever we can our various missions. It is difficult to always have a very quick reaction. Many of the processes that you saw in the wonderful movies and simulations that Alan showed you were within seconds and minutes. These are very, very quick processes. So to have that kind of turnaround on a balloon or a sounding rocket is not always feasible. But as a general rule, we do like to try and coordinate with as many of our assets as possible, and that's one of the reasons that I tried to show our system observatory that we have, is because it is through a distributed network, a large number of observations, that we will make real advancement.
All right, we have another caller on the line, but first to remind the journalists on the phone lines to hit *1 if you'd like to ask a question. Our next question comes from Irene Klotz at Reuters. Go ahead, Irene.
Thanks, Steve. I'm sorry if I missed this. What is the design lifetime of the satellite? And could someone also please give us a overall mission cost, either with or without the launch, however you break it up, separate or together? Thanks.
I'll start with the cost. The cost is just over $181 million in real year dollars, and that includes the development of the spacecraft, the satellite, and the instrument, and also the launch vehicle and management of the whole mission is included. And it has a just over 2-year design lifetime, though, as John mentioned, there are no consumables on board, and there's a strong possibility that IRIS will last much longer than that.
IRIS, which was designed to the same sort of design rules, operated for 10 years. Trace. I'm sorry, I keep doing that. But IRIS Trace operated for a decade, and it was still working just fine when we turned it off. And we turned it off because it was replaced by the Solar Dynamics Observatory.
Our next questions come from Twitter again.
How much of the data obtained by IRIS will be in the public domain?
All of it.
Thank you.
All of it at the same time as the science teams get it. And that's true for all SDO data, and I think virtually all of heliophysics data is made available to the general public at the same time it's made available to the scientific community.
Next question from online.
Someone asks, are there any advantages for future missions to put an IRIS-type vehicle closer to the sun?
I'll take that. We do actually have a couple of missions coming up in another few years. One, a collaboration with the European Space Agency called Solar Orbiter, and one, a NASA mission called Solar Probe Plus. Both of these missions, in fact, are going closer to the sun. Solar Probe Plus will actually fly into the near corona of the sun, and these missions will complement the IRIS type, where IRIS is looking at the base of the solar atmosphere, where the solar wind originates. And these future missions will actually look a little bit further up as the solar wind accelerates and heads out through the heliosphere.
Okay, our next Twitter question.
So if IRIS doesn't have any fuel, can someone help explain how it moves about in space?
Yes, that's really fun. IRIS is launched slightly tilted with respect to the rotation axis of the Earth. And if you think about it a little bit, that if you just launched around the Earth as the Earth went around the sun in only a quarter of a year, you'd be in darkness all the time. But the Earth isn't a perfect sphere. It's a little bit fatter in the middle, like some of us. And because of that, it exerts a force on the orbit. And as a result, the orbit of Trace revolves once around the Earth every time the Earth revolves around the sun. And clever people have figured out exactly where you put a satellite to do that.
Okay, I have a question we received before we went on the air. Will IRIS conduct a survey of the entire sun, one small bit at a time, or will it target only special areas of the sun?
It's a focused mission. It'll target special areas of the sun and won't attempt to make maps of the sun.
Okay.
We have a mission that does that, SDO, and so we don't need to do that.
Okay, one other question. Why are you launching IRIS on a Pegasus rocket instead of a conventional vertical rocket?
Cheaper.
But also it met the mission requirements. And we designed the
Pegasus
mission.
meets the mission requirements. There are a number of assets that do launch spacecraft at this size, and NASA has a methodology that is set out for each of our missions to optimize that mission with the launch vehicle available at that time. And for IRIS, it was we're very happy to be launching on an orbital Pegasus.
Okay, we have one last question at this point. Those fine structures that were shown in the previous graphics, what are those made of?
They're made out of solar stuff, which is sort of 80% hydrogen and about 18 or 19% helium and 1 or 2% of everything else, all the elements that we find on Earth at the level of 1 or 2%. But it's mostly hydrogen with a little bit of helium.
Okay, thank you. Well, that's all the questions we have for today. I wanted to remind everyone that they can follow along IRIS online through social media. On NASA's on quite a few social media channels. Also, as a reminder, the graphics that you've seen today are all available online at go.nasa.gov/irisgraphics. And please continue to follow the mission online all the way up through launch and its interesting findings that will be coming up over the next few years at www.nasa.gov.